Hi, my name is David, and you can't see the presentation yet. I became an Android engineer more than 12 years ago, and I also attended one of the first mobile conferences in Prague. This is me. And I also had an opportunity to speak here at mdevcamp 4 years ago. But as you heard on the keynote, 4 years ago it looked a little bit different because this was my stage and all of you looked something like that. And I thought that I would take this opportunity of me standing here to keep a better memory of it. So if you don't mind, I will take a picture with you so I can share on my next talk. Great. Okay, so now that we have this over with, let's jump into the topic that you've probably came for. Last year, I've decided that I want to implement screenshot testing to our existing application. And I didn't have any previous experience with that. I've only read some articles, I saw some conference talks, and I knew some keywords like shot, paparazzi, and so on. But from everything, it looks pretty easy, so I thought that I will set an estimate of the task to 8 hours, I will be done by 4, and then I can take the rest of the day off, you know. But as usual, it was not as simple. And I thought that I will take you to the journey of me finding some solutions and to present you my final solution that I came up in the end. But let's start from the beginning. What is even the screenshot testing, or it's also referred as snapshot testing, but I will use this screenshot terminology. Screenshot testing is a type of UI testing, and the idea is that you will take a picture of your screen or its a part, you will save it somewhere, and then later on during the testing, you will take the picture again, and you will compare if these images still match. If they do, you probably didn't change anything and your application isn't broken from the UI perspective, but it may happen that, for example, you've changed some color on one places and it's used somewhere else where you didn't expect it. Also, the idea is that you can also take this picture under a different configuration, so you can take a look at how this screen looks on a different Android version, on a different locale, in a different mode, you can test light or dark mode, and so on. This, of course, doesn't check any behavior. It's only based on the comparison of the images, but it detects the unwanted changes just like any other testing. We have two phases during the screenshot testing. One of them is recording, which happens usually during the development, where you take these images and you store them to some storage, and usually these screenshots or the images are referred to as golden screenshots. And then during the testing, there is another phase called verification, and this usually happens during testing, for example, on the CI, where you will take these images again and you will compare them with the golden ones. So let's try to write a simple pseudocode of such a screenshot test. First, we need to prepare the view. So it can be an XML, it can be an activity, it can be a composable function, and you will set the parameters as you want. So you will pass some, for example, arguments to the composable function, or you will inflate the XML and set some attributes on it. Then if you have the view, you will take an image of it. And then, depending on the phase, if you are recording, you will just save the golden image somewhere under some name, or if you are verifying, you first need to retrieve the image by this name and then compare it if they match. If they don't, the test will fail. If they do, the test will succeed. So let's take a look at the first two parts of this, and it's the preparation of the view and creating the image. So over the years, Google has provided us with a lot of ways how to do properly UI testing, how to properly do the UI testing, and they also provided us with a lot of packages and dependencies for it. For example, we can use the Android X test package, where is the activity scenario from which we can launch some activities and we can set our XML layouts on it. Or lately with the Compose, they introduced the Android X Compose UI test package, where we have the Compose content test rule, to which we can set our composable code, and then we can perform some assertions and so on. So let's take a look at a simple example. For example, if I have this composable simple function that contains a button with some text, I can create a preview for it so we can better visualize it, and it looks something like this. And then imagine that I would like to take a screenshot of this composable function. Then I will start a new class. I will create a new class called screenshot test, and I will use this compose rule. Just as a disclaimer, this talk will be heavily oriented on the compose world, because that's the realm that I was implementing it in, but the most of the concepts are applicable to XML as well. Okay, so since we have created a compose rule, now we can write the test, and on this compose rule there is a set content function to which we can set our greeting composable, and that's it. The view is prepared. Now how to take a picture of it. If you are the experienced Android developer, you know that there is several ways how to take a bitmap out of an activity or of a view. For example, lately in the core KTX package, we have the toBitmap method on a view, or if you are using this compose test rule, as I was, there is a method capture to image, and you can call as Android bitmap, and this will return you the bitmap as well. So if we'll take the previous example a little further, we have this content set, and now if we will perform some matches which are necessary for us to actually retrieve the view, then we want to take a picture of it, and I'm just taking the root view and the first occurrence of it. Then I can call the capture to image and as Android bitmap, and this will return me the bitmap. And then I will save the screenshot somewhere, but let's talk about it later on. So speaking of a compose preview, which I've mentioned, just let's quickly summarize what are they used for. In the old XML worlds, we were used to writing an XML layout in Android Studio, and we saw the preview of our layout right next to it. Compose works a little bit differently because we need to introduce these new functions, which will be displayed in the Android Studio, and it's a kind of a similar thing as the preview in the XML, but it's more powerful since we can create a multiple of these functions, and we can also apply a different configurations and the parameters of this composable, and so we can better visualize it. And since I've mentioned something similar about the screenshots previously, it kind of served a similar role. And some smart people in Airbnb realized that as well, and they have created the library called Showcase. The Showcase is an annotation processor library, which during the compile time scans all your code, and it will create a list of all of your preview functions. And it will present them in this Showcase or in the catalog through which you can click through, and you can, for example, present it to a new colleague on the team who wants to implement some new feature, and he wants to see what all of the UI elements your application uses, what your design system is there set up, and so on. The great benefit of this library is that we, as the developers who integrate this, also have an access to this list of all of the previews. So it means that if we would use this list in a parameterized test, it means that I can use all of the previews which my application already have, and I can use it as an input to my screenshot tests, and I can use these previews as a screenshot test. This is great for integrating screenshot testing to new projects, because then you don't have to manually set up each of the view, and the premise is that you have already created some previews during your development of your UI, so you can easily use it. So let's take a look at the implementation of a simple implementation. Since usually the dependencies from Google are prepared for JUnit 4, I will also use parameterized test in JUnit 4 testing framework, which means that I will use the test parameter injector class dependency. And for that to work, I need to annotate it with the runner test parameter injector. And then I need to write a preview provider, the provider of this of the parameter values, and the showcase will get me this showcase.getMetadata.component list of all of the previews. And then if I have defined this provider, I can write my test, which will accept this parameter annotated with the test parameter class. And this showcase browser component contains a component method, which will return me the content of the preview. And I can set it to my compose test rule, and as showed earlier. Then it's also, okay. So that's how to use the showcase for retrieving all of the previews. But since we have introduced the parameterized tests, we can also expand it a little bit further, because as I was talking earlier, we can also generate the screenshots for different configurations. So for example, I can generate my screenshots with a different font scale, so I can see if the text scales correctly in, for example, in my buttons. And I can also generate the screenshots in a light or dark theme. So I need to add a little bit of code for this to work, of course. So for the dark and light theme, I need to wrap my my preview with the theme definition and specify if I'm using a dark theme or not based on the parameter. And for the font scale, I need to do this composition local magic, where I need to override local density by multiplying the font scale property on the current density. And just by this, for a simple single button, first, it's also a good idea to add the arguments to the name of the file, so you can easily know what attributes corresponds to this image. So now, just for this single composable, we can generate 8 of the different combinations for all of the combinations of the variant of the font scale and the mode and the theme. And you know, it's arguable if this is even like desired, because not everything of it makes sense. Maybe it would make sense to split it to more methods, but hey, it's up to you. Okay, so we've talked about the preparation of the view and creating of the image, and let's talk about the second part of this pseudocode, and it's the saving and retrieving the images. If you think about it, these tests, Android tests, instrumented tests, usually run on some device. And is it where I would like to have my images stored? Probably not, because you know, like probably you want to run your test in a CI. There is not the same device as you are testing it locally. The memory of the device can grow quickly and so on, so it's probably not the best place where to store them. So you probably want to store them in your Git repository. But if you run your test, the images are probably stored in the device, so we need to somehow pull it out of the device and store them to your repository. And you also need to perform the verification of the test. So how to do that? Let's first take a look how the common open source library usually does this. There is several of them. I will first talk about the ones that actually need the actual device to run while you are using them. The first one is Shot. The second one is the beautifully named library called Screenshot Tests for Android by Facebook. And the third one is Dropshots, which is a pretty new library from Dropbox, which was released last year, I think. What all of these have in common is that besides the actual dependency that you need to specify in your build file, you also need to specify a Gradle plugin. And this Gradle plugin will generate tasks for recording and verification of the screenshots. And usually this task is dependent on the connected Android test task. And once you run your Android tests, it will run this task, and it will pull the images out of the device through a db command and store them somewhere where you set it to. Yeah, that's what I said. And also during the verification phase, it will also perform the comparison, and it will report you if your screenshots match or not. I have to mention this library because that was kind of a revolution a few years ago. It's called, the library is called Paparazzi, and it's backed by Square, or it's a cash app. And I was in DroidCon Berlin in 2021, where John Rodriguez, I think, the author of the library, presented it. And it was kind of a revolution in the screenshot testing because it doesn't require the emulator or the device to run, and it runs only locally on a JVM. The idea is that if you think about the Android Studio and how does it display your previews or XML layouts, it also doesn't require any device to actually render the view or the composable function. So they thought that why can't we use it as well and use the same renderer as the Android Studio does and use it for generating the images in the screenshots. And that's exactly what they did. They perform a lot of hacky ways how to combine all of these dependencies that they need to depend on and how to connect it together, but it works. But I waited. This talk was, I think, in October, and I waited almost a year for the 1.0 release to finally happen because probably it's a pretty difficult task to pull it out. And after we've tried to use it, we've used it for several months, it turns out that actually this layout lib, which they use for the rendering, is also dependent on the Android Gradle plugin version, which depends on a Gradle version. So that's one thing. Another is that it also depends on a Compose version. And every time we updated any of this, the test started to fail for some unknown, cryptic reason, or it didn't compile, or we needed to perform some hacks through reflection to actually make it work. And the releases of the library were quite sparse back then, last year. So we couldn't wait until the library will release the new version because, for example, we wanted to use a new Compose version. So that's how it felt to increase the new version of any of this, what I've mentioned. So after some testing trial, we have decided that Paparazzi, we will not use Paparazzi, even of the great benefit of running the tests on a JVM without the emulator. Okay, so what now? Because we want to run the tests on a CI, and what options do we have? So the first thing is that we can use the Android emulators, but probably you are Android developers, so you know that the emulators, especially on a CI, are not a really reliable solution. It usually requires some additional setup. Usually you need to write some shell script, which will wait until the device will boot. And also the emulator may freeze. And your test will become flaky, and you don't know why, if it's because your tests are actually failing, or it's because of the emulator. And usually the emulators are resource heavy, and the machines that we are running our CI in are not so resource heavy for the budgeting purposes. So yeah. So another option what we have is to have a physical device, which I will connect to the server which runs our CI, and this device will be connected there all the time, and our screenshot test will be run there. But usually the CI runs in a cloud, or you don't have even access to a physical computer that the tests run in. And also, it's not reliable because the operating system may restart and so on, so you would need to check it regularly. And then there is another option to use the remote farms, for example, the test grid or Firebase test lab. But since all of the libraries use this ADB to pull the images out, it usually doesn't work with the ADB because the device is not running on the same computer as the test is. So you would need to perform some additional work to actually pull the images out. That didn't look very well, but then I have remembered that Google has released something called Gradle Managed Devices, I think 2 years ago. And what the Gradle Managed Devices is, that you will define your emulator definition in your Gradle script. And Gradle plugin will take care of the starting of the device, cleaning up, and also they perform some caching mechanism to speed up the startup of the image of the emulator. They also cache some test results, so if nothing happened, nothing changes in the code, they will even start the emulator. And then you can have a consistent environment for your UI tests to be it on your device or on your local machine or remotely in the CI. They've also introduced a concept called automated test devices, which are the special emulators, which are resource light. And they disable some hardware rendering, they removed some pre-installed apps, they removed some background services which run there. And so this is like ideal solution because you can run this in the CI without it being resource heavy. What they do if you define such a device is that they will create a Gradle task which follows this structure. It contains the device name, the build variant, and the suffix Android test. And this will run all of your tests on this device under the build variant that you choose. So this looks great because that's exactly what I would like to use. But unfortunately, this also doesn't work with the screenshot libraries, because if they run their task to pull the screenshot out of the device, it's already closed, and the task fails. So I felt like this. But after my frustration ended, I was searching internet a little bit deeper, and I found in the testing samples repository on the official Android GitHub this test, which is called screenshot test, which is exactly what I was searching for. And in the documentation of this test, they say that when this test is executed via Gradle Managed Devices, the saved images are stored in some deep folder in the build folder. And if I took a look at the implementation, they will just call something similar to what I already did, and they will just call a method write to test storage. So it means that if I would run the tests on the Gradle Managed Devices, and I will store the images to this test storage, I don't need to bother with pulling out of the images out of the device, because it is done automatically by this Gradle framework. So I've decided that to proceed further, I will implement a custom solution which will gather all of this information that I found out during the research. And what I've decided to do is that I will use the Gradle Managed Devices to be the device that will run my UI test. I will use the showcase for the previous retrieval, because because we have already had the application which was mostly in Compose, so we had tons of previews already. And I will need to write the Gradle plugin and some tasks to perform the verification of the tests, but I took an inspiration from other open source libraries. So for the Gradle Managed Devices, this is how you define them in your Gradle script. It's pretty easy. You will just define the name of the device, on what API level you want it to run, and the system image resource. I have used the ATD, the Automated Test Lite emulator, and that's it. For Showcase, I've used the same code that I've already shown for the parameterized test. The single change I needed to do was to write the image to the test storage. So that was it. And just after doing this, when I ran my UI test, I can find the screenshot in my Git repository or in my project folder deep down in the build folder. So another step I needed to take is to write the Gradle plugin, which will copy the images from this folder to more desirable location in my repository, and then also to perform the verification. And that's what I mentioned now, and I will run this new task after this task that Gradle generated for my Gradle Managed Device. This is a lot of code. I have attached the full implementation to the end of the presentation, so if you are interested and you can take a look. I've just took the most important parts here, but writing a Gradle plugin is a little bit verbose, so sorry for that. But quickly, I first iterate over all variants that my application has. So it's like all of the combination of the flavors and the build types. And for each of these variants, I iterate through each of the managed devices that I have. And for each of this combination, I will create the tasks. First, I will define the name of the task that I want my tasks to depend on, and this follow this pattern that I've showed earlier. So let's just explain what this test task name means. And then I need to create the record screenshot task and verify screenshot task. The record screenshot tasks only copies the files from this build folder from this deep folder in a build folder to my desired location, and it will run after the test task. The verify screenshot task is split similar. I will define where the new screenshots are stored, where is the location of the golden screenshots, and where I want my failures to be stored at for me to visualize them in a CI, for example. And it will also run after the test task. For the image comparison, it's good to realize that you are running this on your local it's not running on a device, but it's running on a JVM. So it means that you can use dependencies like AWT and so on, and there's tons of them for comparing the images. I've taken inspiration from the dropshots because they've also introduced their own library for this. And they have some class called Simple Image Comparator, which allows some thresholds. So you can actually say if you need a perfect pixel match of your images, or if there can be some threshold. And it will also return you a mask with a div telling you what actually differs in those two images. And that's useful because I can create some failure image. So on the left, on the right, we can see the accidentally changed background of the button. On the left, you can see the golden image which I have stored, and in the middle is the div, and by red, we can see what actually is different in those images. And that's it, but you know, because not everything is usually so green, we had to face some challenges along the way. The first one was that since you start to save files, binary files, being images in your Git repository, it will quickly, the Git repository will quickly grow, and the good solution for this is to use the Git LFS, large file system. It's a third-party extension on a Git, which works that it will save these files to remote storage, for example, in GitHub, and your Git repository will only contains references to these images, so it doesn't need to track all of the files in the Git itself. Another challenge was that some views, for example, Web Map, Google Map, or WebView, usually doesn't render really well in previews. And our test failed. Our previews, which contain these views, usually failed. So how we solve that is that we are passing down our own composition local provider property, which we check during in the layouts. And for example, if we normally use map view somewhere, we will provide some fake view, for example, just an image of this map. So we present something meaningful in the preview or in a screenshot, but we don't let the test fail. This one was interesting because one of our colleagues actually had the older Intel CPU Mac. And it turned out that if you save these images, they are the same on a pixel level because there is 100% match, but the binary files are a little bit different. So that means that Git mark all of these screenshots that my colleague has generated as new changes, even though they pixely matched. But it made the pull request process unbearable because there was tons of files marked as changed, even though they were not changed. So we just solved it pretty easily. We bought the new Mac to our colleague, but before it arrived, we solved it by not replacing the screenshots in a disk if they pixel matched. Yeah, another one was asynchronous images. For example, if you are loading some images from the URL, you cannot do it in a preview, but we are using Coil for loading the images, and it allows you to set a custom image loader, and you need to set it in the application class and in a test runner. And I have a code for it, but it's not so important, but you can easily do this. And we've solved it by, for every such an image which needs to be loaded from the URL, we are returning some debug image. And lastly, what I want to mention is that the Gradle Managed Devices are not so reliable after all. And usually on our CI, it failed with this. And the error was something like snapshot setup ran successfully, but the snapshot failed to be created, blah, blah, blah. This is likely to a disk of space for the snapshot, which was not the case because there was a tons of space, and this is just some error which usually happens on the CI if you are using the Gradle Managed Devices. So this was my feeling for the Google, but luckily this is not happening really often. So how we have solved this is that we are checking for the output of the test, and if it failed because of that, we just try to retry the job, and usually it helped. And that's it. So that was our solution that we have used, and thanks for the attention.
Thanks. So we have several questions. The first one, can I use screenshot testing when there is an animation in my layout, for example, Lottie animation?
Usually no, because you could probably use a different, well, you can disable the animations and the preview will look somehow, but you cannot probably render the preview as a GIF, which would contain the animation. But I think that Paparazzi has something in their documentation about Lottie, but I'm not sure now.
Okay. Next question. How long did it actually take you to implement this solution?
Great question. I think that like the time it took me, like it took like 2 to 3 months to like iterate on it, but by just like the actual spent time, I think it would be like 1 week or something like that.
A week of your life. Can you compare test execution time between Paparazzi solution and the GMD solution?
Yeah, I was actually surprised that the GMD solution was not so slow as I expected it to be. It like we had hundreds of the images, and and it took like 2 minutes to run the GMD tests, and for example, a minute for the Paparazzi solution. So, like, since it's not something that I run usually on my computer and I need to wait for it, it's run on CI. I didn't find the difference so important, so significant.
Mm-hmm. Have you considered using Figma screens as gold images?
No, it didn't even occur to me, because usually the designs are not one-to-one to the implementation per se, but it's an interesting idea if it may be somehow implementable.
Mm-hmm. What are the most usual findings by UI tests?
Usually it were just some small changes in the paddings, or if we have changed some UI component that we didn't expect to be used on some places in the app. So I don't think that that it discovered something huge. I would say it were mostly small changes, but it's usually some colors and the sizings between margins and paddings.
Mm-hmm. How and when do you update golden screenshots when Composable is updated and or new created? Is it handled on CI or left to the programmer's discretion?
Yeah, so usually if the CI task failed because of the screenshots comparison, it was up to the developer if he forgot to regenerate the screenshots or if there is an actual error. And usually what we came up with is that we had some script that we usually run locally before we push the code to the PR, and it also contained some linting and so on, so we've included the screenshot testing as a part of this, so it basically ran before each of the PR, this comparison.
Mm-hmm. Great, and the last question so far, do you build the app every time during the test on CI, or do you handle caching somehow?
Yes, we use caching. I think we build the app every time, but we cache the build folders of our modules based on I think the dependencies and the Gradle version. I think. Well, yes, we cache the build outputs, build folder outputs, but not the app itself.
Perfect. Thank you very much. If you have any more questions, David will be outside at the speakers table during the break. Remember to rate the talk on Slido. We will play the poll live now, so you can rate it. It's a great feedback for all of us. Thank you very much again. We are perfect on time, so now you have 10 minutes of break, and then we will continue with more talks. See you later.
Thanks.